Hey everyone, welcome back to the channel. Today we will learn about one of Python's coolest features, decorators. These powerful tools let you modify or extend functions without touching their core code, making your programs cleaner and more reusable. In this tutorial, we will break down how decorators work and build some practical examples. Let's start with the basics. Decorators wrap functions to add reusable functionality without altering their code. Think of it like wrapping a gift. The original function is the gift, and the decorator adds a fancy wrapper like logging or timing without changing what's inside. A decorator is typically a higher order function that returns a wrapper function, which then replaces or enhances the original function. The add syntax in Python makes applying decorators super clean. Common uses include logging, authentication, and memoization for efficient coding. For example, in a web app, you could use a decorator with a wrapper that verifies users' login status before allowing access to a protected API endpoint, keeping your code modular and secure. Let's break down a wrapper function works in Python. Everything begins with the original function we want to enhance. When we apply a decorator, Python actually wraps that function with another called the wrapper function. As soon as this wrapper runs, it can perform pre-processing steps like logging or checking inputs. Then it calls the original function, passing in all the arguments using args and key args for preserving all kinds of parameters. After the original function finishes, we can also do post-processing like modifying the result or cleaning up. Finally, the wrapper returns a value, either the original result or something completely transformed. Let's get started with a simple example. Let's create a decorator to log when a function is called. This is a classic use case for debugging or monitoring. Let's type logger decorator func. So a decorator takes a function as parameter. We will see it in detail. You have to define a wrapper function in order to manipulate the original function. So you can use any name, say define wrapper is just a convention, by the way. You can use another function name, say wrapper. Let's print f calling function func dot name. Here learned a special attribute named name, so you can access a function's name using this attribute. Then call function, the one sent as a parameter. After that, print f finished function func name. After that, we can just return this wrapper. So when you call this function, it will return this wrapper instead. So it will first print calling function, then it will print finished function. Between this, it will execute the function. Just type return wrapper and just define your function. Say def greet print hello. So how you can use this decorator? Here is a critical point. You have to use at syntax. So just type at, type your decorator's name. But we have called this logger decorator. So you will type logger decorator. And after this, we will call it directly in the code. So call greet. So we are expecting that it will call this function, but it will use its decorator and the decorator will wrap this function. So let's remove this. Okay. Now, if we run it, it says calling function greet, hello, finished function greet. So if you add this decorator to multiple functions, it will work for them too. But what if our function takes arguments? Let's define def logger decorator func def wrapper args kw args. We use args and kw args to make the wrapper accept any number of positional or keyword arguments. It was a special syntax if you remember. And print f, you can just print something like this. So func.name access name attribute, access args, and access kw args. And result equals func args kw args print func.name finishes. We will return result. After that, return wrapper. Now, if you want to call the decorator, just use add syntax again. So logger decorator, define add numbers, say a comma b, return a plus b. So if we try to print it, print add numbers, say 5 and 10, and run it. As you can see, it prints add numbers, the name of the function, arguments 5 and 10 in a tuple, and kw args, and it says add numbers finished, and the result is 15. We also return the result of function to ensure the decorator doesn't break functions that return values. This makes our decorator reusable for almost any function. You might ask why kw_args is empty, because no keyword arguments are provided here. Let's type a equals 5 and b equals 10, and if you print it again, as you can see now, kw_args is not empty because we provided keyword arguments. Now let's build a more practical decorator. How long a function takes to run. This is super useful for performance testing in real-world projects. Type import time def timer underscore decorator function, define wrapper, again args kw args for accepting keyword parameters too, say start time equals time.time. So time.time helps us to assign current time to start time, and result equals function args kw args and underscore time equals time.time. So now current time again. Time.time returns the current time in seconds. So by using start time and end time and assign them the current time, it measures the time passed since. Now print f function dot name took end time minus start time seconds. So you can format this like 0.4f or similar things. So now we return result. After that, we return wrapper. And let's define our function at timer decorator. Define, say, flow computation and time.sleep. And so it will simulate a slow task. Return and multiplied by 2. Time.sleep delays the execution for a given number of seconds. If we print slow computation in example 5 and run this, now we are waiting for it. It will make function delay for 5 seconds. So it says slow computation took nearly 5 seconds and it prints out the result. This decorator measures the execution time by recording the start and end times around the function call. You could use this in a web app to monitor API endpoint performance or in a data pipeline to optimize slow computations. Notice how the decorator keeps the original function's logic clean and it adds new functionality. You can also stack decorators here, but the order matters. Bottom decorators apply first. So let's type log decorator func and just copy the wrapper. Now we don't measure the time, just type. Now if we do something like this, add log decorator and print this, we are waiting for it. As you can see, it first runs timer decorator, then log decorator. That's it for Python decorators. We have explored how they wrap functions to add reusable functionality, built logging and timing decorators, and seen their power in real-world scenarios like measuring execution time. I hope you are excited to use decorators in your projects. If you like this, give it a thumbs up and subscribe for more Python tutorials. Thank you for watching.